Hello, my name is Michael Duda, and in this presentation, we're going to look at the steps to run the WRF preprocessing system for a basic single-domain simulation. In this lecture, we're going to spend most of our time going through the steps to run the WPS for a single-domain simulation. If you're interested in running a nested simulation, it's important to first understand the material in this presentation. After that, you can move on and watch the Nesting in WRF lecture. So when we talk about the steps to run the WPS, we're going to first spend some time going through domain setup with the Geogrid program. We're then going to talk about how we can pre-process Grib files with the Ungrib program. And then we'll lastly see the steps to running the Metgrid program. After we've done that, we'll spend a little bit of time looking at some of the utility programs that are distributed with the WPS and why you might make use of these utility programs. Lastly, we'll spend just a couple of slides looking at some common mistakes, and in particular, these are mistakes for which we don't provide very good error messages in the WPS. So starting in with the Geogrid program, the first thing that we need to do when we set out to define our model domains using Geogrid is to edit a file called namelist.wps. This namelist.wps file is a Fortran namelist file, and it's a simple text file that you can open and edit with your favorite text editor. As a general rule, when running any of the WPS main programs, there are two namelist groups that you need to edit. In all cases, you'll need to generally make edits to the shared namelist group that's shared by all of the WPS programs. And secondly, you'll need to edit the namelist group whose name matches the name of the program that you're running. So in this case, before running the Geogrid program, we'll edit the Geogrid namelist group. So in the shared namelist group, there are only two variables that you need to set before running the Geogrid program. The first of these is WRF core. This tells the Geogrid program whether it's setting up an ARW model domain or an NMM model domain. The default is ARW, and this being an ARW tutorial, you generally don't need to change the value of WRF core. The second variable is max domain. This is the number of domains that the Geogrid program is going to process. If we're setting up a single domain simulation case, then the number of domains is 1, in which case we set max dom to 1. Inside the Geogrid namelist record, we need to first choose a map projection, as was discussed in the fundamental capabilities of the WPS lecture. So for our example, we're going to flatten out the Earth's surface using a Lambert conformal projection, and we're choosing the true latitudes of that projection to be 30 degrees north latitude and 45 degrees north latitude. And we're setting the standard longitude, in other words, the longitude that will be oriented parallel to the y-axis in our model domain, at 105.25 west longitude. This happens to be the longitude through Boulder, Colorado. After we've chosen a suitable map projection, we can then specify the geometric center of our simulation domain, and we do that with the reference latitude and reference longitude parameters. So in the Geogrid namelist group, we're going to set reference latitude to 40 degrees north latitude and 105.25 degrees west longitude. That happens to be the latitude and longitude of Boulder, Colorado. Next, we need to specify the size and resolution of our model domain in terms of grid spacing and number of grid points. We can first specify the delta x and delta y values for our model domain as 15,000 meters or 15 kilometers. So the spacing from one grid cell center to the next, ignoring map scale factors, is going to be 15 kilometers. We can then specify that our domain has 220 velocity staggered points in the west-east direction and 175 velocity staggered points in the south-north direction. So we can estimate the expanse of our domain by multiplying the number of points times the spacing between them in both the west-east and south-north directions. Although we have different parameters for the delta x and delta y values, we generally always set these the same. Lastly, we need to specify the path of the geographical datasets that the Geogrid program is to interpolate onto our model domain. These are datasets that we downloaded typically at the same time as when we downloaded the WPS source code, and here with geog data path, we simply specify the path on the file system where those datasets have been uncompressed. Geog data res, as we'll see in the advanced WPS lecture, is a way to specify different sources or resolutions of geographical data, but for this simple example, we'll simply leave it set to default. So after having made those changes to the nameless.wps file, there's no other files that need to be edited, and we can directly run the Geogrid program to create our model domain files. When the Geogrid program starts running, it will write out to the screen and also to a log file the number of entries that were parsed from this file called geogrid.tbl. We'll spend some time in the advanced WPS lecture talking about this Geogrid table file, but for now we can ignore it. Next, the Geogrid program will tell you how many domains it's processing, and the fact that we're processing one domain is good because that's the value of max domain that we had set in our nameless file. After that, as we described in the fundamental capabilities of the WPS lecture, the Geogrid program computes latitude and longitude at every one of our grid cells. It computes map scale factors, Coriolis parameters, wind rotation angles, and a few other fields before going on and interpolating global data sets for land use fraction, topography height on mass staggered points, and many others. After the Geogrid program finishes running, we should see a message that says successful completion of Geogrid printed to the terminal screen and also to the geogrid.log file. So it's always important to verify that the success message was printed to the terminal screen and to a log file. If not, it's usually an indication that something went wrong when the Geogrid program ran. The Geogrid program usually does a reasonable job at catching errors in namelist settings, so it's worth opening up the geogrid.log file and looking for error or warning messages. In some rare cases, the Geogrid program may simply crash with a segmentation fault or other system error. In that case, it's still worth checking through the log file to find some clues as to why the Geogrid program may have failed. After the Geogrid program finishes running, we should have a netcdf output file called geo_em.d01.nc. And as with all of the WPS programs, it's worth taking a look at this file using, for example, NCView, to verify that the contents of the file look reasonable. So after we've set up our simulation domain using the Geogrid program, we can pre-process some meteorological data using the Ungrib program. As with the Geogrid program, we need to make some changes in the nameless.wps file, and in this case, we need to edit the shared namelist record and the Ungrib namelist record. In the shared namelist record, there are just 3 variables that need to be edited. The first of these is start date. This specifies the date at which we begin processing Grib data. The second of these is end date, and this specifies the date at which we stop processing meteorological data from Grib files. And then the third variable is interval seconds. This specifies the interval at which the Ungrib program will write out intermediate files. Typically, interval seconds is chosen to be the interval at which we have Grib data, but it can be chosen to be a higher temporal frequency, in which case the Ungrib program will simply do a linear in time interpolation to that specified interval. This is useful if you happen to be combining different sources of Grib data that are provided at different frequencies, in which case you can temporally interpolate to a common frequency using the Ungrib program. In the Ungrib namelist record, there's typically a single variable that needs to be set, and this is prefix. This gives the prefix of the intermediate files to be created by the Ungrib program. It's worth pointing out that this prefix can include path information. So for example, we could specify the prefix of the intermediate files to be /scratch/data/gfs if we wanted the Ungrib program to write its output to a scratch disk, for example. After editing the nameless.wps file, the next thing that we need to do is to link or copy the correct vtable into our run directory. Various vtables corresponding to different sources of Grib data are provided with the WPS in the WPS/Ungrib/variable tables directory. For example, we have vtables for GFS data, for ECMWF data, and for various sea surface temperature data sets. The key point is that the Ungrib program always expects to find a file named simply vtable in the run directory, with no suffix. So when linking or copying, we need to make sure to remove that suffix. Besides a vtable, it's also necessary to link the Grib files themselves into our run directory. This is because the Ungrib program expects the Grib files to have a particular naming convention: gribfile.aaa, gribfile.aab, gribfile.aac, and so on. If you're working with just several Grib files, you can manually create these links on the command line. However, if you're working with a larger number of grib files, you may wish to use a C shell script that's provided with the WPS called linkgrib.csh. An example of using this script on the command line is as follows. We can say linkgrib.csh and then any sort of shell expressions that match the grib files to be linked into our run directory. After running this script, we should expect to have the required names for grib files, gribfile.aaa, aab, aac, aad, and so on. Once we've edited the namelist file, symbolically linked the correct vtable, and symbolically linked all of our grib files into our run directory, we can run the ungrib program on the command line. When the ungrib program starts up, it tells you the range of dates that it expects to process. These correspond to the start date and end date that were specified in the namelist file. And for every time period of grib data that the ungrib program finds, it prints out a table to the terminal screen and also to a log file. So the first column gives the pressure level of the field that was found in one of the grib files, and the first row gives the name of the fields as described in the vtable file. So an X means that the U field was found at pressure level 2001, and an O means that this field was not found at this level. It's worth pointing out that the ungrib program and the rest of the WPS use two special codes to refer to surface and sea level. So 2001 is the code that's used to indicate surface data, and 2013 is the code that's used to indicate sea level data. After the ungrib program finishes running, just like with the Geogrid program, we should expect to see a message printed to the terminal screen and to the log file that says successful completion of ungrib. As with Geogrid, if this message is not printed, it's worth checking the log file, which in this case is called ungrib.log, to see if there's any indication of what might have gone wrong. One common mistake is to use an incorrect date format when specifying a start date or end date in the shared namelist group. Another common mistake is to accidentally symbolically link files that are not actually grib files into the run directory. However, assuming that the ungrib program has successfully run, we should expect to have several intermediate files in our run directory. In our example here, these are called GFS:2006-0401-00, 06, and 12 UTC. Now that we have set up a model domain with the Geogrid program and pre-processed some grib data with the ungrib program, we can horizontally interpolate those meteorological fields from grib data onto our model domain using the Metgrid program. Just like with the other WPS main programs, we need to edit the namelist.wps file, and this time we're going to edit the shared namelist group and the Metgrid namelist group. In the shared namelist group, there are 5 variables that we need to set. However, it's very likely that these variables were already set when we ran the Geogrid program and ungrib programs. However, if we hadn't already done so, we would need to set wharf core to ARW. We would need to set max DOM to 1 because we're processing a single domain. We would need to set start date and end date to the times over which we would like to horizontally interpolate meteorological data from intermediate files. And we would need to set interval seconds to the interval between intermediate files to be processed by the Metgrid program. Again, all of these variables were probably already set when we ran the Geogrid program and ungrib program. In the Metgrid namelist group, there are 2 variables that we need to set. The first of these is called fgname. Fg here stands for first guess and is simply an indication that this is the data set that will be used as the first guess or initial conditions and also boundary conditions in our model simulation. In the simplest case that we have just a single grib data set, fgname in the Metgrid namelist group is typically set to the same thing as the prefix in the ungrib namelist group. If we do have an intermediate file that contains fields that we would like to hold constant for our entire model simulation, we can specify the full name of that intermediate file with the constant's name namelist variable. After making edits to the share and Metgrid namelist groups and saving the namelist.wps file, we can run the Metgrid program. When the Metgrid program runs, to the terminal screen and also to a metgrid.log file, it prints the information shown on this slide. So the first thing to be printed is the number of domains that are being processed by the Metgrid program. In our case, we're processing just a single domain, so Metgrid says processing domain 1 of 1. If we had optionally specified an intermediate file that contains fields to be held constant for a model simulation, Metgrid will process that file first. The horizontally interpolated constant fields will then be replicated for all other time periods. In any case, Metgrid will then enter a time loop from start time to end time every interval seconds, and for every prefix specified in the FG namelist variable, Metgrid will process that intermediate file with a given prefix at the time period being processed. Assuming there were no errors, the Metgrid program will print to a log file and also to the terminal screen the message "Successful completion of Metgrid." If not, as with the other WPS main programs, it's worth checking the log file to look for any indication of what might have gone wrong. After Metgrid has successfully run, we should expect to have a set of netcdf files in our run directory named met_em.d01 with a year, month, day, and hour from start time to end time every interval seconds. So now that we've talked through the steps of running the WPS for a basic single domain simulation, we're going to take a look at some of the utility programs that are distributed with the WPS and that should be compiled when you compile the WPS. So besides the three main programs, Geogrid, Ungrib, and Metgrid, there are various utility programs that are provided with the WPS. These utility programs can be used for checking the contents of intermediate files, for listing the contents of Grib1 or Grib2 files, to help you in locating your model domains, and for processing, for example, a three-dimensional pressure field for datasets that don't otherwise provide such a field. An example would be the ECMWF model level datasets. Some of these utilities require NCAR graphics, and therefore, in order to install these utilities, you will need to have installed NCAR graphics first. So the first of these utilities is a script written in the NCAR command language, referred to as NCL. The script is called plotgrids.ncl, and it parses the nameless.wps file and produces a X11 plot, showing the position of all of the model domains defined in that namelist. The plotgrid script can therefore be used to iteratively refine the location of your domains. For example, you could look at a plot produced by plotgrids.ncl, decide that you wanted to shift one of your domains northward or eastward, go back, make changes in the nameless.wps, and rerun the plotgrids program. And you can iterate back and forth until your domains are located where you'd like them to be. It's important to note that the plotgrids NCL script only parses the nameless.wps file. You don't actually need to run the Geogrid program in order to see the position of your domains with this script. The next utility is one called RD Intermediate. The RD here stands for read. So this is a utility program that simply reads an intermediate file and prints to the terminal screen a summary of all of the fields found in that file. So for example, we can see that the intermediate file here contained a field named TT, which was in kelvins, and it happens to be temperature. The valid time for this temperature field is 2000 January 24th at 12 UTC. It's from forecast hour 0 of some NCEP model, and this temperature field happens to be at level 2001. And if you recall from earlier in this lecture, 2001 is the code that's used in the WPS to indicate surface data. So this represents a surface temperature field. We can see that the field is dimensioned 185 grid points by 129 grid points, and it happens to be on projection number 1, which corresponds to a Lambert conformal projection, and it has a grid spacing of 40, in this case it's kilometers, so 40 kilometer grid spacing. If you would like to visualize some of the fields in an intermediate file, you can use a pair of utilities to do this. The first of these is int2nc. This is a compiled program that converts an intermediate format file to a netcdf format file. After you've used the int2nc program to convert an intermediate file to a netcdf file, you could directly visualize those fields using something like ncview. An alternative, though, would be to use the plot format nc.ncl script to make nice publication quality plots of the fields in that netcdf file. If you'd like to see a list of all of the fields available in either a Grib1 or a Grib2 file, you can use the G1print or G2print utility programs. These programs take as a single command line argument the name of a GRIB file, and to the terminal screen, they print a summary of all of the fields at all levels found in that GRIB file. This is useful, for example, if you're told by the Metgrid program that your intermediate files are missing a particular level for a field. Using these utility programs, then, you can verify that your GRIB file contains that level of the field. The Calc ECM WFP utility may be used to compute a three-dimensional pressure, geopotential height, and relative humidity field from model-level European center data. The way that this utility works is that you need to first run the Ungrib program to produce intermediate files that contain surface pressure or log of surface pressure, soil height or soil geopotential, a three-dimensional temperature field, and a three-dimensional specific humidity field. The second thing that you need to have done is to create a text file in your run directory called ECMWF-COEFs. In this file, you need to paste the vertical level descriptions for the model level data set that you've obtained from the European Center. After that, you can run the Calc ECM-WFP utility to produce a new set of intermediate files. These intermediate files have the prefix press, and they then contain a three-dimensional pressure, relative humidity, and geopotential height field. When running the Metgrid program, you can specify multiple prefixes in a comma-separated list for the fgname variable. So in this case, we would specify an fgname value of file and also press to combine the fields in the pressure intermediate files and the regular intermediate files. So lastly, we're going to look at a couple of common mistakes made by new users of the WRF modeling system. The first of these common mistakes is to provide the Metgrid program with atmospheric fields that don't all contain the same number of vertical levels. The Metgrid program requires that all three-dimensional atmospheric fields contain the same number of vertical levels. And if this is not the case, the Metgrid program will stop with a cryptic error message shown here. Typically, this error message says, warning dim something, name num Metgrid levels redefined by some variable from one value to another value. It's usually not obvious what this message means, but this is an indication that one or more three-dimensional atmospheric fields do not contain the same number of vertical levels. The easiest way to debug this problem is to set a hidden nameless option, debug level, to a large value, perhaps 1000, in the shared nameless group before rerunning the Metgrid program. Then, in the Metgrid log file, there will be a table showing which fields were found at which levels, and from this table, it should be obvious which fields were missing vertical levels. A second common mistake occurs when using regional data sets to provide initial and boundary conditions for a WRF model simulation. If this regional data set doesn't completely cover the horizontal extent of your WRF model domain, the Metgrid program will stop with an error message indicating that some of the horizontal grid points in your model domain could not be covered by the regional data set. In this case, you'll either need to reduce the spatial coverage of your model domain or find a larger data set from which you can interpolate initial and boundary conditions. Lastly, when using native vertical coordinate data sets for initial and boundary conditions in a WRF simulation, it's important to ensure that you can obtain or compute both three-dimensional pressure and geopotential height fields for that data set. These 3D fields are needed by the real program to do its vertical interpolation. This concludes the How to Run the WPS lecture slides. However, if you're interested, you can stay tuned to see some additional slides without narration.